Good morning, வணக்கம். இன்னைக்கு நம்ம என்ன பார்க்க போறோம் அப்படின்னா thermodynamic derivation of equilibrium constant. Equilibrium constants Kp, Kc, Kx, okay? And band of reaction isotherm. அதை எப்படி derive பண்ண போறோம் அப்படின்னு பார்க்க போறோம். Thermodynamic treatment of law of mass action. அதுவும் இதுதான், ரைட்டா? இப்போ let us consider a reaction. Let us consider a general reaction, reversible gaseous reaction, where A and B are reactants, C and D are products, A and A, B, C and D are number of moles of reactants and products respectively. All the reactants and products are gaseous species. They are assumed to obey ideal gas behavior. They behave ideally. They are ideal gases. The reactants and products are ideal gases. ஒரு reversible reaction எடுத்துக்கிறோம், ரைட்டா? இதுல பாத்தீங்கன்னா எல்லாமே gaseous reactant products, அது வந்து gas ideal gas ஒபே பண்ணுது. ஓகே, அப்போ பாத்தீங்கன்னா the free energy delta G, the free energy of the reaction is equal to the free energy of the product minus free energy of the reactant. The free energy ko chemical potential no என்ன relation? What is the relation between? அப்போ வந்து பாத்தீங்கன்னா free energy of the reactant is equal to A into number of moles of reactant A, chemical potential of A plus B into chemical potential of B. Similarly, the free energy of product is equal to the number of moles of C into chemical potential of C plus number of moles of D into chemical potential of D. Okay. Now, what is chemical potential? Chemical potential is nothing but free energy only. It is nothing but free energy only for 1 mole of pure gas. அதாவது for 1 mole of pure gas எடுத்துக்கிட்டோம்னா the free energy is equal to chemical potential. ரெண்டுமே ஒண்ணு தான், ரைட்டா? ஓகே. At equilibrium பாத்தீங்கன்னா at equilibrium there is no change in free energy. There is no change in free energy. Therefore delta G equal to 0. This is the equilibrium condition. அப்போ delta G equal to 0. Now what is chemical potential of ith component? The chemical potential of ith component, we have derived this in fugacity. Please watch the fugacity video lesson where we have derived this expression, the chemical potential relation. Okay, the chemical potential of ith component equal to chemical potential mu naught plus RT ln P, where R is the gas constant, molar gas constant, and T is the temperature. This is for 1 mole. For n mole na nRT, where Pa is the partial pressure of the component, partial pressure of the component, right? Now where mu naught engadhu enna standard chemical potential when the partial pressure is equal to unity. When the partial pressure of the component is taken as unity, then mu naught equal to mu I naught, right? சரி, இப்போ நம்ம வந்து இந்த delta G, இப்போ வந்து delta G equal to 0. அப்ப GPங்கிறது என்னது? இதா இருக்குது, இந்த இது. அப்ப வந்து நமக்கு என்ன வந்துரும்? C mu naught, இந்த சப்ஸ்டிட்யூட் பண்றோம் இந்த எக்ஸ்பிரஷன். அப்ப C mu naught C plus RT ln PC, okay, plus D, that is D mu naught D வந்து இத சப்ஸ்டிட்யூட் பண்றோம். mu naught D plus RT ln partial pressure of D minus similarly இதுக்குரிய A குறியது A mu naught A plus RT ln PA plus B இந்த மாதிரி வந்துரும், ரைட்டா? This is equal to 0. ஏன்னா Gp minus Ga, the free energy of the reaction is equal to 0 at equilibrium, ரைட்டா? இப்போ நம்ம என்ன செய்ய போறோம் அப்படின்னா, நல்லா பாருங்க, RT இந்த இத நம்ம வந்து இந்த C mu இங்கிட்ட எடுத்துறோம். இத போறோம், இந்த C mu ல அங்கிட்டு கொண்டு போயிருக்கு, அதனால மைனஸ் ஆகும். மைனஸ் Cu mu naught C plus அடுத்து D mu naught D, அடுத்து மைனஸ் minus A mu naught A plus B mu naught B இது போட்டுட்டேன். இப்போ மிச்சம் என்ன இருக்குன்னா RT ln PC R plus, அப்போ பிளஸ் வந்து என்ன வரும்னா RT ln PC log log AB என்ன log A plus log B என்ன வரும் நம்ம log AB நம்ம போடுவோம் அப்ப வந்து ln RT ln PA to the power A வந்துரும் இந்த PC to the power C அடுத்து PD to the power D divided by PA to the power A இங்க வந்துரும் ஏனா அந்த பவர் வந்து உள்ள கொண்டு போய் மல்டிப்ளை பண்ணும் A வந்து இங்க மல்டிப்ளை பண்ணும்போது அப்ப PB to the power B equal to வந்துரும் இது this is nothing but the equilibrium constant we have already seen in chemical equilibrium first lesson okay about the Kp this is the equilibrium constant in terms of partial pressures of products ratio of products and reactants therefore RT ln Kp equal to minus delta G naught this is again you see this is Gp minus Gr but this is standard chemical potential therefore the standard free energy change where delta G naught is the standard free energy change therefore delta G naught equal to minus RT ln Kp this expression is called bank of reaction isotherm this reaction is called this gives the relation between the standard free energy change of a reaction and the equilibrium constant and the equilibrium constant it may be Kp or Kc or Kx okay now let us see this expression that is 4 this is 4 Pc to the power C partial pressure of B to the power D divided by partial pressure of A to the power A partial pressure of B to the B and therefore you bring it here delta G by RT this will come here delta G therefore logarithm therefore it can be expressed in the exponential form the logarithmic form can be expressed in the if you take logarithm then you will get this for example if you get logarithm then minus delta G naught by RT ln okay so if the next step if this is for therefore we have thermodynamically derived the equilibrium constant in terms of partial pressure. Similarly, in terms of mole fraction, what is X here? The equilibrium constant in terms of mole fraction. Now, if similarly here mu I, the chemical potential of ith component is equal to mu I naught plus RT ln Xi. In terms of, for example, in terms of partial pressure, this is the equation we have used. This is the chemical potential expression for the reactants and products expressed in mole fraction or in concentration or in terms of concentrations. Okay, then similarly XCAC. Okay, we can derive this or we can write like this similar to that Xc to the power C, Xc to the power mole fraction of C to the power C, mole fraction of D to the power D divided by mole fraction of A to the power Ax equal to Kx. This is the equilibrium constant in terms of mole fraction. This is the equilibrium constant in terms of partial pressure. Okay, similarly, instead of mole fraction, if the concentrations are expressed in moles per liter, Ci, that is moles per liter, then concentration of C to the power C, concentration of D to the power D divided by that is equal to Kc. This is the expression we have derived thermodynamically நம்ம derive பண்ணிருக்கோம் in terms of concentration. இப்போ இது வந்து we have assumed for ideal gases. Okay. Now for non-ideal reactants and products, for real gases, then it is the partial pressure is expressed in terms of fugacity. Fixed pressure we are studying in fugacity chapter பாருங்க ரொம்ப முக்கியமான chapter அதுல நிறைய क्वेश्चन கேக்குறாங்க fugacity equal to fugacity க்கு pressure க்கு relation இருக்கு in terms of ஏனா for real gases the fugacity is directly proportional to P therefore fugacity equal to fugacity coefficient where gamma is fugacity coefficient okay therefore F is fugacity and the pressure in terms of therefore Kf instead of Kp this is in terms of fugacity of the reactants and products therefore F of power C, F of D power D divided by, in terms of activity, similarly for reactions in solution, for the reactions in solutionsல இருந்துச்சுன்னா நம்ம the activity அங்க வந்து pressure நம்ம சொல்லுவோம், அங்க வந்து the activity of the reactants and products is directly proportional to its concentration in moles per liter, and therefore A equal to its activity coefficient gamma and C. For dilute solution, for example, dilute solution for low pressure, at low pressure F equal to P, at low concentration A equal to gamma, A equal to C, because gamma equal to 1. Gamma equal to 1. We have already studied. நீங்க ஏற்கனவே பார்த்தீங்கன்னா தெரியும். அப்ப நீங்க இந்த எக்ஸ்பிரஷனை இங்க சப்ஸ்டிட்யூட் பண்ணுங்க. F வந்து gamma P. அப்ப gamma C to the power C, gamma D to the power D divided by போட்டீங்கன்னா into P, C power C, இத போட்டீங்கன்னா K gamma. இது வந்து this is again a constant, K gamma activity coefficient, okay, into Kp. Similarly, you can also write for this is for gas non-ideal, for real gaseous reaction, for reactions in solutions. நம்ம என்ன எழுதலாம், activity coefficient gamma C, இது வந்து activity பதிலா என்ன வரும், concentration of C, இங்க activity coefficient இது சேமா வந்துரும். அப்ப நீங்க போடுறீங்கன்னா Kr, இது வந்து என்ன வந்துரும், Kc ங்கிறது வந்துரும். ரைட்டா? So how this நம்ம என்ன பார்த்திருக்கோம் அப்படினா, bank of reaction isotherm எப்படி derive பண்ணனும், and how we have derived the equilibrium constants by using chemical potential and free energy, that is thermodynamically we have derived the equilibrium constants. Thank you for watching. நன்றி.